The shuffled cards are not independent. Since each card appears in the deck exactly once, as you draw each card, it gives you information about the next card. If the first card is black, the second is slightly less likely to be black, and so on. If your deck were infinitely large, that wouldn't be a problem, but drawing 20 out of 52 cards is a pretty big fraction. The die rolls are independent. The probability of success is 1/6 rather than 1/2, but the probability doesn't have to be a half for the binomial distribution to apply. The events just need to be independent, and in this case, each die roll doesn't affect the outcome of the other die rolls. The search engine case is not independent. Often, if someone doesn't find what they want the first time they search, they'll immediately search again with slightly different words. Those are two separate events, but they're not independent. You would expect the results to be related in some way, but you can't necessarily tell that they came from the same user. The education case is probably not exactly independent, but it's a lot closer. Each student corresponds to only one event, not multiple events. And Udacity students are spread out all over the world. You wouldn't expect two different students to be terribly related. Of course, there are exceptions. Maybe some students create two accounts, in which case we wouldn't know that it's two different students. Or maybe some take courses with their friends, in which case whether they complete would be correlated. But in practice, it would probably be reasonable to assume a binomial distribution here. The shopping cart case is also not independent. For example, one person could add several items to their cart, then purchase all of them. The outcome for these different events was highly related.